Number 11 says solve 8 to the x plus 8 equals 32 to the x. Now, we need to get these so that we can have a common base. In order to do so, let's take a look at the two numbers that are our current power bases. So we have 8 and we have 32. One thing that we know they have in common is they both can be written as 2 to an exponent. So for example, 8 can be written as 2 to the third. So we can write this as 2 to the third to the x plus 8. And then 32 can be written as 2 to the fifth. And that's still all being raised to the x. Now, in order to, so again, we have not changed any values. This is still 8. This is still 32. I just wrote it a little differently. It just looks different. It's literally the same number though. Now, over here on the right or on the left side, when we're working with two numbers or a power raised to a power, you need to multiply your exponents. So in doing so, you're going to take 3 times x and 3 times 8, which is going to give us 2 to the 3x plus 24. Over here on the other side, we're just going to raise 2 to the fifth to the x, so we're just going to multiply the powers of, or sorry, 2 to the fifth to the x, multiply the 5 and the x. We get 2 to the 5x. Now, since we have the same base, we're going to take our two exponents. If we have the same base, that means our exponents have to be equal to each other. So we have 3x plus 24 equals 5x. And now we just solve it like a normal algebra problem. So I'm going to subtract 3x from both sides, and that leaves me with 24 equals 2x. Divide both sides by 2. Sorry, waiting for the screen to catch up. There we go. Divide both sides by 2, and we end up with x equals 12. Now, in case you're not entirely confident with that, you can always go back and double check that and plug them in. You're going to get really big numbers. So you're going to have 8 to the 20th equals 32 to the 12th. It's going to work out, but the numbers are really big, so I'm not going to bother with that right now.